Okay, let's turn the projector back on and continue some. Come on. There we go. Okay, guys, let's continue now. Can you look up? Yeah. So, what we're looking at now, something called the remaining theorem, and why it's useful. So let's imagine you have a problem like this. I might say something like, what is or when, let's just say x cubed plus x squared plus x plus 1 is divided by x minus 1. You know, some question like this. How would we do this? Well, we would calculate the long division and get the remainder. So just to get warmed up, I want you to calculate the remainder. Tell me what you get. Shouldn't take you too long. The numbers are all small. So after the long division, you'll discover at the end that the remainder was 4. Have some of you seen that? You got to the remainder part? Isn't it? It's 4, isn't it? Some of you look confused. The remainder's not 0, right? It's 4, isn't it? Yeah? I don't hear a lot of confidence on this. Do I need to do the long division? I better do the long division. I'm not happy with some of the confused faces that are looking at me. So, long division. This is what you get for skipping breakfast. Okay, so first one is x squared, right? X cubed minus x squared, yes? And then here, 2x squared. So far so good? Plus 2, 2x squared minus 2x, right? Sorry, 2x. That's 3x plus 1, so plus 3. This is 3x minus 3 remainder, as I said, 4. Ah, come on, what's with you guys? It's okay. Are you sure? All right, anyways, I'm continuing. So the remainder is 4. What we would like now, it would be really nice if we could have a formula to tell us the remainder so we don't have to do the long division, right? If we could have some formula that says remainder equals blah, 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 and you just put the numbers in and get the answer, that would be very convenient. So let's try and figure out what that formula might look like. So we'll keep everything general for the moment. We'll say, let's imagine you have a cubic, ax cubed plus bx squared plus cx plus d, and we divide that by something like x minus k. Let's make it nice and clear, k. And we would love some kind of formula that says the remainder is, like how we have minus b plus or minus square root b squared minus 4ac all over 2a. It'd be nice if we could have a formula for the remainder as well. So let's try and work it out. Now this proof is a little bit messy, so I'll just not go too fast. But what we're doing is we're going to divide x minus k into ax cubed plus bx squared plus cx plus d. And then after all the cycles, what we get at the end here will be our formula for the remainder. So let's see what we get. Okay, well the first one is not so bad. What's the first multiplication here? Ax squared. That's okay to start with, right? So that gives us ax cubed minus a, what's next? Ak x squared. Can you see that? That multiplying that. Right. Now we have to subtract. So the first two, obviously gone. These two can be added together. You end up getting b plus ak, right? You get b plus ak x squared. And then these get carried down. Oh, just before I continue, I just want to give this cubic a name. So I'm just going to call it f, just so I don't forget. Just going to give it a name. Okay. Right, now it's getting a little bit trickier. What's the next multiplication here? Who can see what it is? B plus AK X. And then we multiply. So that's B plus AK X squared minus, and then this guy multiplies the K. So that gives us, now I'll put the K inside, so that gives us minus BK plus AK squared X. And then we subtract again. And again, these cancel. And these two, minus minus, makes plus. So you end up getting C plus BK, yeah, plus AK squared X. And then don't forget, this D gets carried down. Oh, sorry, this D here gets carried down. Now I know it's looking very messy, but the good news is there's only one multiplication left. Isn't there? Yeah. Yeah, there's only one left. It's plus bracket and the whole thing. C plus BK plus AK squared. Right, let's multiply it out. So it's the same thing, isn't it? And then the last one is that multiplied by minus K again. So that'll be minus bracket CK plus BK squared plus AK cubed. Now don't worry, we're finished now, because what is this subtraction going to give us at the bottom? It's going to give us the remainder, which will be D plus CK plus BK squared plus AK cubed. Yeah? Now just to make this look a little bit neater, I'm just going to write my formula out starting with the cubed. So the formula for the remainder is AK cubed plus BK squared plus CK plus D. Now, where on earth have we seen something like that before? Yeah? Does it look in any way familiar? Yes. It's the question, isn't it? Except with a small change. What's the small change? Yeah, instead of X, we have K. So that's equal to FK. You see it now. Now, listen. I know that proof is quite long, but the result is extremely useful. Listen, guys, look. What you're saying is if you want a formula for the remainder, the formula is actually the question itself. The actual question is also the formula for the remainder. Now, before I let you write that down, I'll give you an example. If I go back to the one I just did, this is the cubic, right? So, that is also the formula for the remainder, except instead of x, we replace it with 1 in this case, because in this formula here, it was x minus k. What's the k here? It's 1. So if I put 1 into this, 1 cubed plus 1 squared plus 1 is 4. So it works. Yeah. Yeah. Okay. Now, write this down carefully. The result is very important. I'll put the result here. Fx divided by x minus k has remainder equal to f of k. Just be careful with the signs, all right? And lastly, just before the question there, if you had something a little bit trickier like fx divided by, I don't know, let's say px minus q, if there was 2 numbers in it. Does anyone know what you do then?
Q over P?
Yeah, q over p. Okay, so write this down, please. All right, question? No, they won't ask you to prove this, but it's a really good thing to have in your notes because it's great practice of the long division. Yeah. Has anybody seen the remainder theorem before?
No.
No?
No.
No. Question, yeah?
Why did you the negative carry over? And if you have a positive, will
That's
you
right, yeah, exactly. If you have a positive, you put in the negative. And if you have a negative, you put in the positive. And the reason you can kind of think about it is like this. If I said to you x minus 3 is a factor, then you say that root is 3. It's kind of like this. Guys, you have that written down? Yeah? Yeah? We see this again in maths, by the way. This is our first example of where the answer is actually in the question itself, or the formula for the answer is the formula of the question. This comes up again. And also for people who've done calculus before, you've seen something kind of like this. For those who've seen calculus before, you would have learned that the derivative of e power x is also e power x. So this is an example of where the answer and the question happen to be the same thing. It's kind of like what's happening here. The question is, what is a formula for the remainder to this cubic? And the answer is the cubic itself is the formula. Okay, in a second now, let's have a look at how we can use this to help us with some questions. Okay, I'm going to scroll down now. So just before we do some tough ones, just a little bit of a practice here. If I said to you 2x minus 7 is the factor, what is the x value? 7 over 2. Yeah. Okay, now you should be comfortable making those changes in your head, you know. And likewise, if I said to you minus 5 over 8 is the root, what's the factor? Very good, 8x plus 5 then. Okay, you just need to be comfortable making those quick changes. It's useful to do. Yeah? But now on to an actual question that requires the remainder theorem. This first one we'll do is not so tricky. What is the remainder when 5x cubed minus 4x squared minus 11x plus 1 is divided by x minus 2? Alright, if you have your calculator, you can do this really quickly. Give it a go there. Tell me what the remainder is. Straight into the calculator. See what you get. So what value of x are you using in the formula? 2, yeah. Got an answer? Perhaps, yeah. Let's see. So it's 5 times 2 cubed, which is 8, minus 4 times 2 squared, minus 11 times 2 plus 1, isn't it? So what's that? 40 minus 16 minus 22 plus 1. Yeah, so that's 41 minus, 41 minus 38, isn't it? So 3 is the answer then. Yeah, that's what you said, isn't it? Yeah. Okay. Is okay? I think some of you got 3, right? Well, let's practice another one. What is the remainder when, let's see, we'll say 10x cubed plus 3x squared minus 18x minus 3 is divided by 5x minus 6. So what's the, that's a minus 3 there. Right, what's the value of x that you're using? 6 over 5. Yeah, give it a try now. So, on your calculator, you should be typing in 10, 6 over 5 cubed, plus 3, 6 over 5 squared, minus 18, 6 over 5 minus 3. And when you type that in, what do we get? Minus, is it? Minus what? 3? Exact? Nice, okay, minus 3. Okay, so we're getting the basic idea. Now on to something more exam appropriate. These are a little bit too easy for the exam. The next example I'm going to do will be a section A question, so a sort of short section A question. I'm going to say, find P given that 2x cubed minus 3x squared plus 8x plus p No, sorry, I don't like it already. Find p given that x cubed plus px squared plus 8x plus 14 has remainder equal to 2 when divided by x plus 2. So what's happening here is there's a piece of the cubic you're missing. You don't know this p here. It's unknown. But what I tell you is, if you take this cubic and divide it by x plus 2, you get a remainder of 2. That's enough information to find out what the p is. I'll give you a minute before I do it. See if you can figure out what the p is. And again, we have to use the remainder theorem. See if you can get it. Got p is 2, is it? Yeah. 3. Okay. I think 3 is the answer. Let's have a look. So, what are we putting in for x? Minus 2. And we know when we sub in minus 2, we're getting the remainder. And in fact, we know what the remainder should be. It should be 2, as we're told it. So that's minus 8 plus 4p minus 16 plus 14 equals 2. So that's 4p equals 2 minus 14 plus 16 plus 8. 12, is it? 4p equals 12? Is it 12? So p equals 3. That's a section A question. Now, let me give you what might be what has been a section B question now. So if you can make sure you have this, please. Okay, can I scroll down? Yeah? This is what a section B question might look like for a few extra marks. Guys look up, find P and Q given that x minus 5 and 5x plus 1 are factors of px cubed minus 19x squared minus 29x plus q. So because these two guys are factors, what do I know about their remainders? They're both 0 remainders, okay? You can probably see what problem this is going to become since I have two unknowns. Yeah. Okay, again, I'll give you a minute to see if you can figure it out, and then I'll give you the answer. This is a section B question in the exam, so see if you can find P and Q here. Yeah. Has she like totally fallen asleep? Oh yeah, that's sound asleep. Just a little nudge of the table is I bet we could all sneak out and she wouldn't even notice. Do we have answers yet for this? Oh, we're awake! We're awake! Bit sleepy? Bit sleepy? No! No! Okay, alright. Could have fooled me. Right. We getting answers for this? Too many fractions. Yeah, you were unconscious. You were completely unconscious at the back. Okay. Yeah, it's a bit messy. There's it's, lots of fractions because of the minus 1 over 5, isn't it? Yeah. No answers yet? Nearly? Okay. Got an answer? Okay, let's have a look at it now. Can we look up, please? You can check how your answer's going. Right, so look, the first one, x minus 5, is a factor. That means it has no remainder. And we calculate the remainder by using x equals 5. So if I put 5 in here, I should get 0. So let's sub this in. 5 cubed is 125, isn't it? And then, what's this? 19 times 25, whatever that is. And then minus 29 times 5 plus q equals 0. Okay, so straight away I can see, before I even add anything, I can divide everything by 5. No, I can't because the q. Okay, 125p plus q equals, so if you take these over, what do you get? 620, like this? Yes. Okay, good. That's our first equation. The second one, we need to sub in what? Minus 1 over 5, isn't it? So that will be minus 1 over 125p, yeah? Yes. Minus 19 over 25 plus 29 over 5 plus q equals 0. Yes? So that's minus... Now, if you want, you could multiply everything by what to simplify it? No, better. 125, yeah. If you really want to, but there's no real need to, because what you can do... just, yeah, what are these two added together? If you take... Like that? Is that right? Yeah. Now, this is nice because I can get the Q. The Q's are I can cancel the Q's. They're the same, right? What do I do? Add or subtract? Subtract. So this will be 125 minus 1 over 125p. The Q's cancel. And that's 620 plus 126 over 25. So since you have the calculator, this is no bother because you just divide this under. So whatever that big fraction is on the calculator, nice. So it works out that p is 5, and then you can sub that back in here, and if that's 5, what's that? 5, 6 to 5, it's like minus 5 or something? Minus 5, yeah? Okay. And there you go, that's the answer, P and Q. So like I said, that would be a section B question in the exam. Okay, if you didn't get that, or if you didn't get it finished, can you copy it down? English, please. Okay. You got that copied? I know it's tricky. Yeah. What's wrong, Aziz? Oh.
The last part.
The very last here?
Yeah.
So you're happy that I subtracted these two. So that's 125 plus 1 over 125.
Yes.
I could have added them on the calculator, but I didn't bother to. And then the Q's cancel, and then it's 620 plus 126 over 25. So that's how come I got this piece. And then I divided that under.
Yeah.
So that way I only need to use my calculator once. Right. About 10 minutes or so left. So we can get a start on these. Question 1 is very short, so all. Question 2. Yeah, it's very short. Look at them. It's like 1 over 5 minus 7 over 9 minus 6 over 5. 1, 2, 3, 4, 5, 6, 7. It looks like 14 seconds. 7 even. Question 2 is the same. A and C. A and C. E. A. Okay, get a start on that now. That's your homework. Get those finished. Yeah, this is the last one.
Yeah.
Let me just, guys, can I close this? Okay, anyways, let's see. So what are you asking me?
I don't understand this.
Ah, no, but you need to ask me something.
I don't understand this.
Yeah, but you need to ask me something.
What?
Yeah, you tell me, what part didn't you understand? So, how did I get this piece here? I put 5 into that. That's fine, isn't it? And how did I get this piece here? Minus 1 over 5 into that. So the that's a plus q equals 0.
Yeah.
Okay? Now, you can use your calculator to clean this up, can't you?
Yeah.
So you can get like 125p plus q equals some number, whatever it is. You just, take that over. And then likewise here you got minus 1 over 125p plus q equals some number by taking this guy and this guy to the right. Now what does this problem look like? If you look at this, you realize it looks a lot like this problem you did.
Again, by taking
Of these two middle tubes to your side, because there's no P and Q in it.
Yeah.
Yeah. If you look at this problem, you realize it looks a lot like these problems. Except instead of having X and Y, what letters do you have? You have P and Q, yeah. So you can do this part using one of these methods. So in my example, can you see here? I used the elimination method because the Q's cancelled.
Yeah.
Q minus Q is gone.
Yeah.
And then I did this minus this. Now I didn't have a calculator, so I left it like that. But if you have a calculator, you can just type that in.
Yeah.
And you got one number here, And then you can do this minus this, you can type it in. Actually, have you got your calculator? Let's see what we get. So look, like here, can you see here? You can do 125 minus 1 over 125. And that gives you that many p's. Now it's a big number, but so what? You have your calculator. So you have that many p's, and then when you do this minus this, that will be 620 minus 126 over 25. You get this big number.
Yeah.
So you have something p equals something, and then you just, divide.
Yeah.
Oh, it's gone now, is it? So, yeah, how do I scroll down? There we go. So when I minus these, they cancel, and what did we get previously? Oh, it's gone, is it? How do I go? Yeah, let's see. There we go. You got 15626 over 125p equals 15626 over 25. So you do this divided by this, and you end up getting p is, I think it was 3. Or 4, or 5, whatever it is, yeah. And then you sub that back into, this one looks fine, and you get the q. That's all. It's not so difficult.
Yeah.
Good, okay. Let me just close this, hang on.